So if an observer is stationary and the source is moving towards the observer, we can use equation number 12.2. So yeah, if the source is moving towards the observer, we can use equation number 12.2a, and that'll give us the frequency, which is f, the frequency when they're stationary, both are stationary, divided by 1 minus velocity of the source. So for our case, it's the train, over velocity of the sound wave. And if the source is moving away from us, so since the steam train is approaching towards us and then it's going away, so for the second case we can use 2b, and that'll give us the frequency, which is the frequency at when both are stationary, divided by 1 plus velocity of the train over speed of sound. Now let's actually mark them. So this is approaching and this is moving away or receding. Okay, so we know these two numbers. So this one right here and this one is given. So approaching frequency is 565 hertz and receding frequency is 486 hertz. So how fast was the train moving? So we need to find out this guy. So that's something we don't know. And for in this problem, we can assume the speed of sound at 20 degrees Celsius. So that's we know, but we don't know this. So what we can do is we can write the equation in terms of the frequency, or the frequency when both are stationary, and then we can equate them. So what I mean by that is, let's write this equation in terms of stationary frequency. So that's going to be f prime, then 1 minus the train, the velocity of the train over the velocity of the sound wave. And for this guy, it's gonna be, so again, let's write approach, and for this guy, let's write recede. So f is gonna be f prime recede times 1 plus velocity of the train over speed of sound. Now, since these two guys are equal, so we can equate these two equations and solve for the velocity of the train. So let's do that. So it's gonna be f prime approach times 1 minus velocity of the train over velocity speed of sound, that's equal to frequency recede times 1 plus velocity of the train over speed of sound. Yeah, so this is something that we don't know. So what we can do is we can write the whole equation in terms of this guy, the velocity of the train. So you can do it on your own, and I'm just going to write down the expression that we're going to get so you can verify that. So it's going to be the velocity of the sound wave, or the speed of the sound wave, times f prime approach minus f prime recede divided by f prime approach plus f prime recede. So now we know all the numbers, so we can plug that in and see what's the velocity of the train. So that's gonna be let me write it here. So it's gonna be 343 meters per second. Then we have 565 hertz minus 486 hertz divided by 565 hertz plus 486 hertz, and that's gonna give us 26 meters per second. So that's the velocity of the train. Thank you.